Hello guys, welcome to this tutorial. Before we get started, I want to let you know that you can find all the code example and resources we'll be using today in the GitHub Repository linked in the video description below. This repository serves as a valuable companion to the tutorial, allowing you to follow along, experiment, and explore the code on your own time. Yes, actually that was my face when I saw the first time all those acronyms. And just pronouncing CSR, SSR, SSG, DSG, ISG, I get an headache before starting the tutorial. But really guys, that stuff is too important. We cannot skip it. It's too important. At the heart of any web application lies rendering, the process of displaying content on the user's browser. Efficient rendering is essential for delivering good user experience. So in the realm of Next.js, rendering takes center stage, offering a framework that simplifies and optimizes this process. We'll uncover the meaning of rendering in context of web development and how Next.js streamlines this incredibly important operation. When we talk about CSR, SSR, SSG, DSG, and ISG, it's easy to get crazy and overwhelmed, but I just want to tell you that I found a way to make it simpler. Just think about these two concepts, where and when. To easily understand, we can divide them in two groups. CSR and SSR answer the question, where should I render? But SSG, DSG, ISG answer the question, when should I render? Actually, what those acronyms means. CSR stands for client-side rendering. In CSR, web content is initially rendered on the client side, meaning that the browser is responsible for processing and displaying the web page. So the server just has minimal HTML and JavaScript, and the browser will create final HTML using the JavaScript React bundle, okay? And SSR, that is stand for server-side rendering. SSR involves rendering web pages on the server and sending the fully rendered HTML to the client. This results in a complete page delivered to the browser, making it suitable for search engine optimization, SEO, and ensuring that users receive content more quickly, especially on the first visit. We have SSG, stand for Static Site Generation, and SSG actually pre-builds web pages at the development stage, generating static HTML files for each page. So these files are then served directly to the user, reducing the need for server processing at runtime. So this approach results in fast page loads and simplified hosting, as there is no need to serve for server-side processing for each request from the user. We have DSG, that is Dynamic Site Generation, that actually is the opposite of Static Site Generation, combines elements of SSR and SSG by allowing for the generation of dynamic content at build time and, if necessary, at runtime. So we have at the end the ISG, that is Incremental Static Generation, that actually is an extension of SSG, where static pages are actually generated incrementally. When content changes, only the affected pages are regenerated and regenerating the entire site. So this optimizes build times and allows for dynamic updates on predominantly static side, offering a compromise between static and dynamic content. Actually, these rendering methods are crucial consideration in web development, each with its advantages and use cases depending on the project requirement. Another important information is that CSR and SSR are referred to component, but on the other side, SSG, DSG, and ISG are referred to pages. So what actually rendering means? Rendering in React actually involves more concept and is a little bit complicated to explain all the single step of the rendering in React. You can understand better this concept in other tutorials specific for React. Here in this part, I just want to give you the basic concept to understand the rendering in Next.js. Actually, in React, as you can see from the image, rendering can be initial. The first rendering when we load the page actually is executing the JavaScript bundle if it's on the client side, and we create the page. So the JavaScript will create the new virtual DOM and create the real DOM and create all the HTML elements, CSS, and also leave a part of JavaScript that we call iteration that actually is responsible to give interaction to the user with the page. So a little part of JavaScript and event emitter and other part are still in the page, okay, after the initial JavaScript execution. From the server actually is the same. The JavaScript run on the server and the final page is created on the server and is sent to the client. So actually, as you can see from the image, the application is composed with different nodes, and every time we trigger a render on the application, React will compare the previous virtual DOM with the new one and will trigger only the changes, only the difference between the two DOM. And this is the powerful part of React that make it more light and more fast to render. So in React, rendering refers to the process of converting React components into a set of instructions that the browser can use to update the document object model, the DOM. React uses a virtual DOM to efficiently manage update to the actual DOM, as we saw. Here is a simplified overview of the React rendering process. As we say, the component rendering, okay? When a component is rendered, it returns a representation of the UI, typically using JSX. We create the virtual DOM that instead of directly updating the real DOM, React creates a virtual representation of the DOM in memory. This virtual DOM is a lightweight copy of the actual DOM. The phase that we call a reconciliation is when the state of React component changes due to the user interaction to other factors. React creates a new virtual DOM representation, then compare the new virtual DOM with the previous one to identify the differences. This procedure is called diffing. And then there is the DOM update. React determines the most efficient way to update the real DOM based on the difference found during the diffing process, then applies only the necessary change to the actual DOM. There is the final stage that is the re-rendering. React components can be re-rendered when their state or props change. React diffing algorithm helps to optimize this process to minimize the number of DOM manipulation required. So, while the core concept of rendering React involves in creating a virtual representation of the DOM and updating the actual DOM efficiently, we know that this actually the main difference between CSR and SSR is about this computation. So where we make the computation, so it can be executed on the client with a bundle. So the client will create a page using a JavaScript bundle. The library Webpack helps React to create this bundle. So the React application code is typically bundled using tools like Webpack, Parcel, or another bundler. This results in a single JavaScript file or multiple file chunks that contains all the code necessary to run the application. This can happen. So this is what happened on the CSR on the client, but on the server, actually all this computation happened on the server itself, and it sent the final HTML, CSS, and JavaScript directly to the browser, to the client. So let's get deeper about the differences between CSR and SSR. So in CSR, in client-side rendering, the majority of JavaScript execution takes place on the user's browser. That's the main difference. When a user, accesses a CSR-powered web application, the server sends, first of all, as you can see on the background, a basic HTML file to the browser, That's just basic. That's just the root element. This file often includes a reference to a JavaScript bundle that's on the script, And once the browser receives the HTML, it fetches and executes the JavaScript, dynamically rendering the content on the client side. So 100% of computation is on the browser, is on the client side. Traditional all single-page web applications were rendered on the client side. In a client-side rendering process, the role of a server is limited to storing the client-side code of the application and data and transferring them to the browser when requested. The user's browser then compiles the code to turn it into an interactive application by adding functionality and generating the UI, the user interface. So adding functionality, it means iteration. It means leave some JavaScript inside the HTML to make the page interactive. The pros of this approach actually is a faster initial page load. Since the server sends minimal HTML payload, the user sees the page more quickly. Enhanced interactivity, the browser handles subsequent interaction, providing a smoother user experience. But actually, the concept that SEO's challenges that the search engine crawlers may find it difficult to index content, affecting search engine rankings, and also the performance on low-end device. So resource-intensive rendering on the client side may lead to slower performance on devices with limited processing power. Contrary to CSR, as SSR involves executing a significant portion of JavaScript on the server before sending the HTML to the client. So this means that the server generates the HTML content dynamically, including the initial data. Users receive pre-rendered HTML directly from the server. So the server is a little bit like PHP. The client receives directly the final HTML. The server generates the initial HTML markup for the server, generates the initial HTML markup for the component and sends that HTML to the client as a part of the initial response. So this helps to improve the time to first render and can benefit search engine optimization SEO because search engine crawlers can more easily index the content. Now let's talk about iteration. Okay, actually client-side iteration is when the client receives the HTML. It also includes the JavaScript bundle responsible for client-side rendering. The client-side JavaScript takes over and React is initialized on the client. The reiteration is when React on the client reiterates the server-rendered HTML, attaching event listeners and making the client-side application interactive. Actually, SSR provide a faster initial render because the client receives a fully formed HTML document from the server, reducing the need for additional round trips. But it's worth noting that not all parts of a React application need to be server rendered. Developers can choose to server render specific components or paging, leaving others to be rendered on the client side. Actually, Next.js gives you this power to decide where to apply CSR and where to apply SSR. So the pros of SSR actually is that is improved SEO. As we said before, better performance on low-end devices, server-side rendering lightens the load on client devices, resulting in faster rendering. Choosing between CSR and SSR, or even adopting a hybrid approach with iteration, depends on your project goals and constraints. By understanding these rendering strategies, you can make informed decisions to create a web application that delivers optimal performance and user experience. When use CSR and SSR, in Next.js, components are server-side rendered by default. Okay, this is the first rule that you have to keep in your mind. Is by default. Okay, so all the root page, all the pages, the upper element of the DOM tree are server-side rendered, and we are going to apply client-side render on the leaves of the tree. Okay, to keep the interactivity for the user. In some cases, Next.js requires a component to be CSR, adding to statement use client. That's really important. We will see later how to apply the use client that actually force the component to be rendered on the client browser. So Next.js forced us to apply CSR, and so we are obliged to use client to declare use client on top of our page or on our component. In one of these cases, it happens when we have in our component some event listeners like on click, on change, on over, and other kind of event listener. When we apply the use state and lifecycle effects like use state, use reducer, use effect, all the actually functional method in React. Also in the case that we use browser-only APIs, and when we use custom hooks that depend on state effects like use effects, and also when you use React class components. So it's time to see something practical, and we are going to see how to create some component and coding to see all the difference between all these rendering types. So let's start playing around with the CSR and SSR. So you can see our project here. You can find all these directly in the GitHub repository under the description under the video. I already created some route with some files to see practically how to apply all these render concepts. So I create the CSR SSR route, the generation route, and some API revalidate method. This part we're going to see now and apply for this special chapter. So let's see the difference between SSR and CSR. Okay, so first of all, we go inside this route. I create a page that import a basic component, some other component like fancy text, inspiration generator, copyright. If we don't put use client, the component, as I said before, is server rendered by default. I console log is server rendered. With this trick, we will see when the component is rendered on the server, because we are going to see that console log directly in the server terminal, but when it's client rendered, we are going to see on the browser console. So this will give us the proof that is a CSR. We see that we get also, for example, the inspiration generator actually is use client. We declare use client here. We are telling to Next.js that this component must be rendered on the client side. We console log directly on the browser, and we will see if it's rendered on the browser itself. And we will see if it's really rendered on the client. Actually, use client lets you mark what code runs on the client, okay? It is needed only if you are using React Server components or building library compatible with them. When you install new packages, new React component, you have to always declare use client. If not, you will get error with Next.js, because use client is mandatory, as we saw before, when we apply use state or any React method. We apply use client at the top of a file to mark the model, and its transitive dependencies are client code. It means that automatically all these components will be also use client, okay? All these components will be rendered on the client side. So when a file marked with use client is imported from a server component, we'll treat the module import as a boundary between server run and client run code. You have to know also that use client must be at the very beginning of the file. And when a use client module is imported from another client rendered module, the directive has no effect, okay? So if we put use client inside inspiration component, it doesn't make any sense because we already declare here. Let's see actually what happened with a typical schema. So I will show you. You can find all this concept on the react.dev, okay? There is a really good explanation about this concept. Actually, I get this image directly from the website. As you can see, in our application, okay, the yellow part is a client rendered, and if we go here to the component, let's see here. So you can see here, this is server. It means the app is server render. Fancy text will be server renders. Copyright will be server render. But the inspiration generator, if we go inside this component, we declare that have to be rendered on the client side, okay? So it means that all component under him will be client because they use client statement. So we see that the fancy text is the same component that will be rendered the first time on the server, and the second time inside the inspiration generator will be client side render. Let's see what happens if we launch the application. As we see here, we can see also another important thing is about we can actually import any use client component on other server component. But if we want to import, okay, some server component inside the client component, we have to use the wrapper, okay? We have to wrap the component like that. For example, here you can see inspiration generator, okay, is a client side, is a CSR component. We are telling to Next.js to render a server-side component inside him. So we can do it only with the wrapper method. So if we go inside the inspiration generator, we will import the children that actually is, in this case, is going to be the copyright component. So in this way, we can make Next.js to render. This will be server-side, but the inspiration generator will be our client render. So if we go from the top of the tree to the leaves, we see that, okay, the page is SSR by default. We import this component, okay, that is server-side component. We will see server-side component, server rendered. All this component is going to be server-side, okay? It's going to be SSR here. This is going to be server rendered. We put inside, we send as a props the comp type server render, so just to console that and have the proof that is going to be server-side rendered. and we add the inspiration generator inside here that we declare on the component is a CSR, but we import the copyright as a server-side render, okay? So let's see how is the import generator. Actually, it's just we use some state. The inspiration is going to be CSR itself. Fancy test in this case will be use client, will be CSR, and here we go. We have everything. Let's see how it works. What we see here, okay, is the app, and let's break down all the console logs. We first see on the server side that SSR CSR comp is server-side rendered, okay? The fancy test is server-side rendered, the copyright is server-side rendered as we plan to do it, okay? Inspiration generator is client-side rendered. Fancy text is client rendered. So let's run our application to see how the components are rendered. So we started. Okay, this is our application here. Okay, so here on the server terminal, we will see all the console log also from the client rendered, the SSR, the fancy text, copyright, and all the other. But if we go to the client console, we will see that only the CSR component rendered here. So this is the proof that the inspiration generator and fancy text is client rendered as we planned before. Let's talk about the static side generation, the dynamic and the incremental one. What is the difference between them? The static side generation actually is a method of building website where the content is, as we explained before, is generated at build time and remains unchanged until the next build. So it's static and will never change. The advantage, of course, is really fast loading times and there is no server-side processing for each request. Simplified hosting, a requirement a static file can be served from a content delivery network, for example, CDN. There is also improved security due to the absence of server-side processing. And on the other side, the dynamic side generation is the opposite one. That is the generation that involves on content and generating content on the server in response of each time a user requests. So this allows for a real-time customization and personalization of content based on user interactions, but actually the advantage are real-time content update, more interactive and personalized user experience. For example, getting data from some API that change many times during the day, to have an app more interactive and personalized with the user experience, and is suitable actually for websites with frequently changing content, okay? So in Next.js, a build time, a route is automatic SSG if there is no dynamic function. This is the first rule. If we don't put any cookies or headers dynamic function in our page, it will be automatically SSG. But if we put cookies or headers, it will be dynamic, okay? Let's talk about pages that they don't have data fetching, okay? With data fetching, we will see later, Next.js will decide to make it static or dynamic depending on revalidate time and the use of cache. We will see in a second step because it's more complicated. So if the page doesn't have any fetching function and if we don't use cookies or headers, it will be SSG. But if we use cookies and headers, it will be DSG. So let's see with a real example. So I prepare this generation route here and this page. I already import some cookies. So I want to see if I use cookies and the page will be dynamic. But first I want to see if I use just a standard page without anything. I want to see if at the build time it will as a static. So we just return some is static page. Let's see. That's important. We can see the behavior, okay, of SSG or DSG or ISG only in build time, okay? Only in production or only after build. We cannot see this behavior with a local host. We're going to build and we're going to start the server like in a production mode. Let's build, pn run build. And during the building, we will get really important information. Let's see. Let's see what happened. Now it's building. The generation route should be static now, okay? Okay, it's building. Okay, all this information are essential because actually tell you what Next.js consider SSG or dynamic or generate with params actually. We can see three different symbols: is an empty circle, is a full circle, and a lambda, okay? And they are referred not to the component but to the pages, to the route. We get some information, but the more important is the kind of generation, okay? Here there is the explanation. You can see if the lambda, it means that the server-side renders at runtime. It means it's not static. This page will change every time the client make a request to that page. So when this empty is static, is SSG, and the full circle actually is the same as static, but we will use this, we will see in the next chapter, when we want to create static page from dynamic route with generate static params, okay? Actually is like in this case, when you have dynamic route, you want to create a build time, many pages depending on some params that we put in a JSON actually, okay? But now we are interested only to the first two cases. As we expect, this page doesn't have any cookies or headers or function or fetch API that make it dynamic. It should be SSG, it should be static. As we can see here, the generation route is static, okay? So it means that it will never change in the future. Let's add the cookies and see if JS will consider that a dynamic, not static anymore. Let's see, we build again, and run build, and here we go. As we expect, now the generation route is dynamic as a lambda, and it means that server-side renders at runtime every time the client will get this page. Actually, it's normal because the page depends on the cookies. It cannot be static forever, but change depending on something dynamic like the cookies. The same is for the headers, okay? If I use these headers, okay, headers method to get the headers from the request, we will also get a dynamic rendered page. Let's see. Let's just wait a little bit. Here we go. Okay, so this time also generation route is dynamic. Okay, let's see what happens when we have fetching inside the page. So this is more complex, of course, because Next.js need to know if we want to refetch the data each time we load the page, or we want to make it static first and then revalidate after, for example, 3 hours, after 1 day, or depending on the kind of fetching. So let's create a page that actually has a fetch function. We get this free API that give us information about cats. This fetch, it means that doesn't have any parameter here about the revalidation. It means that by default, it revalidate every 60 seconds. So it means when there is actually a caching, okay, in the fetch, that it means that with this fetch, I cache for 60 seconds and then I refetch again after 60 seconds. When it's like that, actually, Next.js at the build time will treat the page as a static site generation. But if we put, for example, revalidate 0, it means that I want to change the content of the page each time the client requests the page. So in this case, there is no reason why I have to make static this page, and Next.js will create the page as a static side renders at runtime. Let's see. Let's compare these two scenarios. So the first, now we expect to be SSG. Here, run build. Here we go. We have the generate page as a static page. Okay, but if we put revalidate 0, here, it should be built as a dynamic one. It's 3, and here we go. The generation route is dynamic this way. Let's launch the application and see how it works. In this case, every time I fetch, I load the page, I get a new fetch, I get new data. This is random that each time return different data. So let's see the page. So we start the server. So this is my application. You can see it return a sentence. If we update, we see every time we update, the content change, okay? Because we tell to Next.js to revalidate 0. It means that don't keep my content, keep for 0 seconds. So every time you have to revalidate. Let's see if we change this parameter. We put, for example, 60 seconds, and we build again. Go, start the server, update. So the first time we get a new data, but if we update the page, the data doesn't change. Actually, the page was static, was created as a static page and is cached on the website. So it doesn't change every time we update the page. We build again, try to revalidate after 10 seconds. We get the first content. Now we wait 10 seconds and we should get a different content. Here we go. So after 10 seconds, the revalidate time take action, create a new static page with a new content. Actually, I anticipate what is ISG, Incremental Static Generation, with this example, okay? Incremental Static Generation actually is the feature that enhances the efficiency of the build process in static site generators. It allows to rebuilding only the parts of the site that have changed since the last build, reducing the time and the resources required for updates. So the advantage of ISG, that is faster build times for large website, efficient for resources by avoiding unnecessary rebuilding of unchanged content. So let's see how ISG work actually with a flow. So we can see here that actually there is a build step, the first build step that generate the page, okay? And here is the server, the client make the first request, and the server give back the version 1 of the page, okay? So it responds with HTML, CSS, and JavaScript. There is a display and also the iteration. The client can interact with the page. On the second request, we also get the V1 of the page, but that's depending on how is the revalidation time. If the client make the request after, for example, the revalidation is 10 seconds, if make the request before, like after 5 seconds, doesn't change anything, but after 10 seconds, it will trigger a new static generation of the page. So it's incremental, it's a new page after some condition. The condition can be two different types. The type is based on time, okay, and depend on the revalidate, and the other is on demand. We decide with an API call, we can use the server actions, or we can use also the API route in the route handlers inside Next.js to make a revalidation and a new page generation when we need, okay? So if we trigger the revalidate time, it will respond also with the first V1, but at the same time, Next.js will regenerate the page. So for all the future requests, we will get the V2, the new version of the page. This is actually what is incremental static generation. So let's see how it works with directly with the code. We can use also this page, okay? And I forgot to tell you that before the revalidate 0 is also equivalent to use like Next.js will render as a dynamic. If we also put a cache no store, is the same, or we can also use export revalidate in this way, and is the same, okay, just to know. And if we put revalidate to 0, Next.js will create a dynamic page and not static. Let's see how it works, the incremental static generation. Actually, we already see the concept to revalidate on time with the previous example, we're changing the revalidation time. Now I want to show you how to change the content, how to trigger a new page generation on demand with a API call. We can manage the incremental static generation with the tags, okay? We are telling to Next.js, hey, please be careful that this fetch actually has a tags and this cats. So when I need, I want to fetch again this function and recreate this page with the new data. So how I can call this function, how I can actually trigger the tags and revalidate this page, this fetch, and recreate the page. I already create in the API route a file that actually is a simple get API that use the method revalidate tag with next cache, and when we make the request, okay, it's going to be just a get request with some parameters. We will put the parameter my tag. We will add to my tag the value that we put here, that is cats, and it means that it revalidate this tag, okay? And we get a response for the API. Here, if you see, I make just after the revalidate tag a call to the page. I load the page to trigger the first revalidate, because what happened? If I don't make this call, actually Next.js revalidate, but the next time a user will load the page, it still see the previous version, okay? You need to trigger once more time to get the new version. So I anticipate this, and I just fetch the page, so I'm sure that any user that will load the page after my revalidate tag will have directly the new version. No need a second page loading to see the new version. So let's see. So we build again. Run build. Here we go. We start the server. Let's open the page. So the page is this one. As you can see here, if I update the page, doesn't change. Okay, it doesn't change because we say to Next.js here in the generation route, we say, hey, just revalidate, refetch only with the API call, only on demand. That's why I don't see new content on this page. But if I make an API call directly to this API route, let's see what happens. So this is the URL, as you can see, is the same, is the API revalidate route, and we put some parameters. My tag is equal to cats, as we saw before. So if I put this, I will get the response. So it's revalidated. Here is the timestamp. So now we should get a different content. And here we go. It works. We have reached the end of this video tutorial, and I genuinely hope you've enjoyed its content. If it has been helpful to you, please show your support by liking the video and sharing it with your friends on social media. If you haven't already, I warmly invite you to subscribe to my channel to stay updated on upcoming lessons. Don't forget to check out my website, devergolabs.com, where you will find a plethora of interesting programming content. You can also send me collaboration requests and explore all the programming services we offer. Your participation and support are crucial in my growing and to grow this community and providing you with even more valuable resources. Thank you from the bottom of my heart for being here with us, and I look forward to seeing you in the next video tutorial.